All right, so today's lesson is about the binomial theorem. I'm going to be using past papers to explain this topic just because we're so short on time, right? So as we go through each past paper, I'll explain the process and the approach to take based on the question. So as the term binomial suggests, we're talking about a polynomial with two terms. So for example, a plus b, that would be a polynomial. Now, what the theorem is about expanding a binomial raised to some power, right? So, for example, you may want to expand 2 plus x squared. And that's easy enough. We know we would write 2 plus x times 2 plus x, and then we would distribute. We can do the same thing with cube, maybe to the 4, and so on. But as n starts getting bigger and bigger, it becomes more tedious to do the expansion. So what this topic will allow us to do is to do the expansion without having to write out however many of them and distributing. This is our first question that we're going to attempt, and in attempting it, I'll go through the formula that we're going to use and so on. So it says, show that the binomial expansion of 1 plus 1 over 8 x to the 8 up to and including the term in x to the 4 is this. So it's saying when I expand this, I'm expecting to get this. It's a show, so we know where we're headed. Now, the binomial theorem, or rather the binomial expansion formula, is on your formula sheet. So I'm just going to copy and paste it here and then use it or show you how to use it. All right, so this is the formula that is on your formula sheet. And this is what we're going to be using for our expansion. So here we have a plus b raised to the nth power being equal to a to the n plus, we know this notation means nc1 times a to the n minus 1 times b plus nc2 a to the n minus 2 times b squared plus dot 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 all the way up to plus b to the n. Now you can see the pattern. The pattern is NC0, NC1, NC2, NC3, and so on, up to NCN. And then the A, that's the first term in your bracket, starts at a power of n and reduces by 1 in each term. So a to the n, a to the n minus 1, a to the n minus 2, a to the n minus 3, all the way to a to the 0, which is 1, which is why it doesn't appear in this last term. And then times in each term you have b to the, starts at 0 and then increases, the power on the b increases by 1 as you go on each term. So b to the 0, which is why it's not shown here because that's 1, b to the 1, b to the 2, b to the 3, all the way up to b to the n. And this, there are actually two formulas that we're going to be using. This one is used when our n is positive and an integer. So in this case, my n, which is 8, is positive and an integer. And so this is the formula that we're going to use. All right, so we're going to expand 1 plus 1 over 8x to the 8th power. In this case, you can see that my a is 1 and my b is 1/8x and my n is the 8. So the a is 1, the b is 1 over 8x, and the n, the power, is 8. And we're just going to take those numbers and plug them into the formula, and we're going all the way up to the x to the 4th term. When we expand this, the last term would actually be the x to the 8th term, but all they require of us in this case is to go to the x to the 4th term. So that is where we will stop. So plugging in, we have a to the n, so that's 1 to the 8th, plus nc1, so that's 8c1, times a to the n minus 1, times b, which is 1/8x. That takes care of the second term. Third term, nc2, so that's 8c2, times a to the n minus 2, so that's 1 to the 8 minus 2, times b squared. Now, this is where you need to be careful. A lot of students make the mistake and write, for example, 1/8x squared, like that. But the b is 1/8x, which means if you square b, the 1/8x needs to be squared, not just the x. When it's written like this, it's just the x that you're indicating that you're squaring. So it's important that your 1/8x, your b, is in brackets in this case and squared. Plus, next term, 8c3 times 1 to the 8 minus 3 times 1/8x in brackets cubed, and then we have one more term because we're going up. This is the x cubed term, so we need one more term to get to the x to the 4th term. So that's going to be 8c4 times 1 to the 8 minus 4 times 1/8x to the 4th power. And then we're going to turn to our calculators to work these out now. So 1 to the 8 is 1. 8c1 is 8 times 1 raised to any power is 1. So all these ones that are being raised to a power, those will all give us 1, right? So I don't need to write those in. I'm just going to write the 1/8x plus, and then 8c2, which gives me 28 times, and remember, this 1/8 that is in the bracket needs to be squared. So we're going to plug that in, 1/8 all squared, and that gives me 1/64 with the x squared term, plus our 4th term now, which is 8c3, that's 56 times, I need to cube the 1/8, so that's 1/512 x cubed, plus final term 8c4 gives me 70 times the 1/8 raised to the 4th power gives me 1/4096, and then the x is raised to the 4th power. If we go ahead and simplify this now, you can check it. It's going to give us what we have up here, 1 plus x. So if you put this into your calculator, 28 times 1/64, you're going to get 7/16 x squared, plus, if you plug this one in, you're going to get 7/64 x cubed, and then finally, if you put this one in, you're going to get 35/2048 x to the 4. And that's what we wanted to prove. And that is part 1 of this question. Let's look at part 2. Part 2 says use the expansion now, the expansion that we just did, to approximate the value of this 1.0125 to the 8th power. So we're using the fact that I'm just going to copy and paste this is equal to, and remember, even if you did not get part 1, it was approved, so you have the expansion available to use. Even if when you attempted to do it, you didn't get it, you can still use it in part 2. All right, so we're going to use the fact that 1 plus 1 over 8 to the, x raised to the 8th power is equal to this in order to find 1.0125 to the 8. Now, if you match them up, if you equate them, you have the same power of 8 on the outside, right? Both have the same power of 8, which means we're going to equate the inside of the brackets. So we're going to equate the 1 plus 1 over 8x to the 1.0125. And then we do that, solve for x, and use that x now to plug into the expansion. So let's make x the subject. I'm going to subtract 1 from each side and divide by 1 over 8. When I do that, I get 1 over 10. Right, so the value of x as 1 over 10. If I should plug 1 over 10 here for x, what I end up with in the bracket is 1.0125, right? That's what I want, being raised to the 8, which means I would plug in the same x on this side. So therefore, 1.0125 to the 8th power is equal to 1 plus x, which is 1/10, plus 7 over 16 times x squared, so that's 1/10 squared, plus 7 over 64 times x cubed, which is 1 over 10 cubed, plus 35 over 2048 times 1 over 10 to the 4th power. If I plug that into my calculator, I get 1.10, let's do one more decimal place, 1.104. Let's test to see the actual value of 1.0125. So let's plug 1.0125 to the 8th, and I get the same 1.104. So we know to at least 3 decimal places, this approximate value is actually equal to the actual value of this.